we're looking at 4 slope of parallel and perpendicular lines. All right, example 1. A hill and a gondola line 20 feet above the ground that goes up the hill both have a slope of 1/2. Okay, so the hill and the gondola line both have a slope of 1/2. And the gondola line is 20 feet above the ground. What is the geometric relationship between the hill and the gondola line? Okay, so one thing we need to remember from algebra is our slope-intercept form. Okay, and that slope-intercept form is y equals mx plus b. Change. Okay. So our slope-intercept form is y equals mx plus b. A reminder what our m and our b are. So m is the slope, b is the y-intercept. Okay, so I want to create an equation for each of these two lines. So my line for the hill would be y equals m, which our slope is 1/2, x plus b. B is our y-intercept where it's crossing our y-axis. Well, here it's crossing at 0, so I would just leave it as y equals 1/2 plus x. My gondola line, y equals our slope, which is 1/2 as well, times x plus b. Our y-intercept on this one is 20, so plus 20. Okay, so what can we conclude from that? We can conclude that our hill and our gondola are gaining 1 foot of height for every 2 foot of horizontal distance. Try it. Suppose another line for a chairlift is placed at a constant distance c from the gondola line. What is an equation of the new line? Is the new line also parallel to the hill? Okay, so if we're going to place a chairlift a constant distance of c below the gondola line, that means that we would be subtracting it from our equation. So we would have y equals mx minus c. And if I want to take that a step farther and put it in comparison to our gondola line, we would have our slope of 1/2 still, minus or plus the 20 minus the c that we're taking away for that constant distance. Okay, and then it also asks if the line will be parallel to the hill. Yes, it will be parallel because it has the same slope as the hill. two non-vertical lines are parallel if and only if their slopes are equal? Okay, so again, this is from algebra. So two non-vertical lines are parallel if and only if their slope is equal. Any two vertical lines are parallel. Okay, so vertical means it is going straight up and down, so it has to be parallel because both of their slopes would be 0. All right, so next we're going to check for parallelism. Let's see if I can get this straightened out. All right, so we want to check and see if lines K and N are parallel. So to check to see if our lines are parallel, we want to see if they have the same slope. So to see if they have the same slope, first I want to identify some coordinates. Okay, so K, I'm trying to find some easy coordinates here. So it looks like there's an intersection here and here. Okay, so I'm going to use those two coordinates. I'm going to go ahead and write those. So the first one is +2, -3. And then the next one is -2, -2, +2. And then our N, an intersection and an intersection. So 1 and 2, and then 4 and -2. Okay, so now I'm going to check my slope for each of these lines to see if they have the same slope. -3 -2 over. Okay, again, you're just using the slope formula to check this. 4. Okay, so that's one of our slopes. Check the second slope. And 4 -1. Okay, so I can see that my two slopes are not the same. They're not equal. So these two lines are not parallel. Okay, or try it. We're going to do the same thing, but this time we want to look at lines M and Q. So I'm going to identify points on both of those lines. So M looks like -1 and 4, and -4, 3, and then Q, 1 and 0, and -4 and -2. Okay, I'm going to find my slope. So again, on this one, I do not end up with the same slope. So no, they're not parallel. Okay, so next, two non-vertical lines are perpendicular. If and only if the product of their slope is -1. A vertical line and a horizontal line are perpendicular to each other. Okay. So one thing we might remember from algebra is that when we're finding the slope of perpendicular lines, we're looking for the negative reciprocal. So we can either try to find the product of the slopes and see if they're -1, or we can just see if they are negative reciprocals of each other. I think I spelled that wrong, but okay. So a negative reciprocal, we would be flipping it and turning it negative. So if I had 2/1, the negative reciprocal of that would be -1/2, and so on. So you're just flipping it and you're making it negative. If it's already negative, then you make it positive. Okay, let's look at example 3. If lines J and K are perpendicular, or our lines J and K are perpendicular. So we want to find the slope of J and K and then determine if they are negative reciprocals of each other. So to find some points for J, looks like -1, 5, and 1, 2. K is -3, 2, and 0, 4. I'll find my slope for J. Then find my slope for K. Okay, so my two slopes, I have 3 or -3/2 and a +2/3. Well, those are negative reciprocals of each other. So yes, these are perpendicular. Okay, let's look at the triad. So we want to find if lines H and L are perpendicular and lines K and M are perpendicular. Okay, let me find some points. I'm going to put them up above. So to find my slope of H, and 4 minus, no, Nope, I flipped those, hold on. 1 minus 4. 2 over negative 3. Then my slope for the second line. Okay, so no, those are not perpendicular. And then K and M. All right, we already found our slope or our coordinates for K, so we can use the same coordinates. And then M. And we'll find the slope. Okay, so B is also a no. All right, example 4, we want to write equations of parallel and perpendicular lines. All right, so they're asking us for the equation of the line that goes through P that is parallel to line L. Okay, so if it needs to be parallel, that means we want the same slope. And we're using the point P, so 4, 1. So I'm going to plug in y as 1. Actually, let me backtrack just a second. This might help us understand it a little bit better. So the equation of our line right now is y equals 1/2 x minus 3. Okay, our y we know, for our new line, we want it to go through 1. So I'm going to go 1 for y. It has to have the same slope, so it's parallel. So 1/2. Our x, we want it to go through the 4. But we don't know what the b is. We don't know what the y-intercept is, where it's crossing our x-axis or our y-axis. So I'm going to do plus b. Now I'm going to solve this for b. So b is -1. So then to write my equation of my line, y equals 1/2 x minus that one I just found. All right, now we want to find a line that is perpendicular to L that goes through point P. So we're going to do the same thing, but this time instead of having a slope of 1/2, we want to use the negative reciprocal. So our perpendicular slope needs to be the negative reciprocal of 1/2, which would be -2. So again, I'm going to plug in my y of 1. My slope this time is -2. Plug in my x of 4. And we're solving for b. Okay, so my b is 9. So I'm going to plug that in. Y equals, my slope is the -2 plus 9. All right, try it. What are the equations of the lines parallel and perpendicular to the given line K passing through point T? So this time we need to find both parallel and perpendicular lines. Okay, so I'm going to plug in my y. 1 equals, we're going to leave our slope the same for parallel. So I would find b is equal to 10, so plug it in for my equation. My slope stays the same. So there's my perpendicular line, or my parallel line. Now I need to find my perpendicular. So again, I plug this in. My slope on this is negative reciprocal, so the negative reciprocal of -3 is positive 1/3. Okay, go ahead and simplify this before I subtract over. So I'm going to end up with 0 for b. So again, I'm going to put in my negative reciprocal slope. And I don't really need the 0 in there, so I can leave it at that. All right, we'll do that again. -2 equals, we want to leave our slope the same for our parallel. But didn't plug in my x. That looked weird. Okay. There we go. That looks better. Okay, plug in my b, so y equals 3/4 x minus 11. Okay, last one is our perpendicular. Again, I need to use negative reciprocal of my slope, so my 3/4 becomes negative 4/3. And then plug that in.